So example 4 wants us to answer the question, how is a composition of reflections across parallel lines related to a translation? There's no other way to get the graph here than other two-click solution. So we're just going to kind of go through what they did. So they started with triangle ABC here. Okay. And they did the first one, they reflected across the y-axis. So that was this axis right here. Okay, so there are two ways to do this. The first way is you can just count. So B here is 6 to the left of the y-axis. So if we go 6 to the right, there's going to be B prime. A is 7 to the left, so if we go 7 to the right, there's B prime. C is 5 to the left, so if we go 5 to the left, there is C prime. The other way we know if we're reflecting over the y-axis is to simply change the coordinates, the x coordinates. So if we were to write out our points here, A is going to be negative 7, 2. Oops. Which means A prime, right, is going to simply be 7, 2. Right? B is negative 6, 6, which means B prime is going to be 6, 6, 6. Okay, C here is negative 5, 1, which means when we reflect over the y-axis, C prime is going to be 5, 1. Okay, which is what they have here. So you can simply count, right? They have to be equidistant away from that line of reflection. A and A prime need to be the same distance away. B and B prime need to be the same distance away, and C prime need to be the same distance away. Or you can use our rule, right? XY is going to be, when reflected over the y-axis, XY goes to negative XY. Okay, and then we have to do a second reflection. They chose the line X equals 4. So they then reflected over the line X equals 4 here. So this was the y-axis. This is now the line X equals 4. Okay, the y-axis is also known as the line X equals 0. Okay, but we're now reflecting over the line X equals 4. So B is 2 to the right. So we're going to go 2 to the left. A is 3 to the right. So we're going to go 3 to the left. And then C prime is 1 to the right. So we're going to go it's 1 to the right. So we're going to go 1 to the left. Okay. So those two reflections, basically you flip it one way, and then when you reflect it back, it's going to get flipped back over to its original orientation. So the idea here is when you do two reflections, that's going to be the same thing as a translation. So here, if we reflect over the y-axis and then reflect over the line X equals 4, line M here, we're going to get a translation that's the same as just simply shifting everything 8 to the right. So a double reflection over parallel lines is going to be the same as a translation. Okay, and that was the idea there. So a double reflection is the same as the translation. Okay, I'll help you out a little, I guess, with the try it here. Right, so it says suppose line N is the line with the equation y equals 1. So then they're giving you triangle DEF, the vertices, D, E, and F. And they say, what is the translation image that's equivalent to those two reflections? So you're going to need to reflect these points, D, E, and F, over the x-axis. And then you're going to need to reflect them over the point y equals 1. And then figure out which translation is the same as doing those two reflections.